study it, and so on. All right, so what we have are two atoms here. We have a neutral sodium atom, and we have a neutral chlorine atom. Okay, you got your periodic tables?
Yes.
All right, tell me about the sodium atom. We did this on Friday, all right? And we're using the marbles to represent the parts of the atom, the particles in the atom. The green ones are the protons, the blue ones are the, and the yellow ones here are the electrons. This is the nucleus, these are the electrons. Okay, all right? Tell me about a sodium atom. It has what? How many protons does it have?
11 protons and
How do
11.
we know that?
Because the atomic number.
All right, the atomic number is 11. That means we also have how many electrons?
11.
11. I'm not going to worry about the neutrons for this particular lesson, but it does have 12 neutrons. Its total mass is what? 23. 23. That's its atomic mass. All right. Chlorine. So we have 11 protons, 11 electrons. All right. Chlorine. Tell me about chlorine. Cl.
Chlorine.
Protons.
17.
17. I've got 17 protons here. All right. You can count them, but trust me, they're there. All right. Unless I miscounted. I might have. All right. But I don't think so. And then I've got 17 protons, which means I have 17 electrons as well. Why are they both neutral? Why are they neutral? Raise your hand. Why are they neutral, Leo?
Because they have the same amount of protons as electrons.
All right. Same amount of protons as electrons. What if I were to give this another neutron?
That would still be neutral.
I'd still be a neutral atom. Neutrons have no charge. All right, just for drill, the atomic mass of the chlorine atom is 18. No, sorry.
17.
No,
I mean,
35.
35,
35. No, you're right, 35. So I've got 17 electrons, which means I must have how many neutrons? 18. So I've got a total of 35 particles here. All right. And we're going to be focusing on, what did I do?
You can kick that one.
Put an electron into the nucleus, that can't happen. All right, so we're going to be focusing our attention on what we think are the electrons that are involved in bonding these two atoms, pulling these together. Our idea is that there's some sort of magnetic force between them. The problem is they're both neutral atoms. So how could they possibly be attracted to one another magnetically if they're both neutral? One of these might have to be negative, and one of these might have to be positive. And the idea is somehow the electrons are involved. We can't exchange or move protons. Why? Because if we do, what are we going to do?
That would make a complete different
All
element.
right, now we get a totally different element here. Now, sodium chloride, table salt, okay, its formula is NaCl. It's one atom of chlorine, one atom of sodium in a molecule of table salt. We're just going to try to figure out why they're actually bonded together. What is holding them together? What is pulling them together? We think it's magnetic force. We think somehow, this was our hypothesis in the room, we think somehow electrons move from one atom to another to change their charge. Does that make sense?
Yeah.
So if I were to remove electrons from chlorine and give them to sodium, it would now become what charge over here?
Positive.
If it got electrons, it would become what charge? Negative. But if I lose electrons from chlorine, the atom now becomes positive, and that might hold them together. So we're going to see how this might possibly work. All right, so the first thing that you have to understand, I'm on page 2 now, okay? I'm just going to talk, but you guys follow along with me in the narrative, page 2. Not page 3, page 2. Electrons are arranged in a certain way around atoms. They're not just thrown randomly around the atom. They are arranged. Now what you saw in these models on Friday, and some kids were asking about them, was that we have levels here, and we have holes in these levels, or places to put the marbles, spots to put them. Well, there's a reason for that. Because electrons are arranged in a specific way around the nucleus of an atom. They're arranged in what are called energy levels. I call them shells. That's the way I was brought up. That's what I was taught to call them, and it's easier than saying energy levels. Just too many syllables, okay? But it's based on the electron's energy. The ones that are further away, all right, the ones that are further away have higher energy than the ones that are closer to the atom, all right? but they're in different levels, and you can kind of see how the model shows different levels. Now you have to also imagine this is not the scale, and the electrons would be very, very far away. But there is an order and a number for each level. In any atom, the first level can only hold how many electrons?
2.
2. Look at your sheet. 2. That's the limit. 2. No more than 2. If I try to put a third one in there, there's no place for it to go. The next level, the second level away from the nucleus, further away from, would have how many electrons? 8. Okay? The most it can hold is 8. Third level, what's the most it can hold? 8. Okay? That's the first thing we have to know, and that's the first thing that we have to understand. All right? Now here's what you need to understand, though. Now I'm going to tell you the key to this whole thing and why we have molecules. I'm going to give it's just one reason. One reason. One reason why we have molecules. You're about to know the secret to chemistry right now. It's pretty simple, really. I don't know why this happens, but every atom, all atoms, every single one, wants a complete outside shell of electrons. That's what they want. Now, this is chlorine. Does it have a complete outside shell? It's got 7 in its outside shell. Does it have a complete outside shell? Does it have room for 1? It wants 1 electron. Okay? It's not happy unless it gets 1. But what happens to its neutrality? It's not neutral anymore, but it doesn't care. It would rather have a complete outer shell than be neutral. That's what it would rather have. I don't know why that is. Somebody probably knows. I just don't know. All atoms want complete outer shells of electrons. And this is the driving force behind forming bonds. It's the driving force. That they want to have complete outer shells. So now go to page 3, and we're going to start with chlorine.
I get it. I see it.
Okay? I know you can probably see it now. But you guys actually kind of figured it out before we even got here, all right? Which is great, all right? So I want you to think about this now. Let's take chlorine. I'm going to take the electrons off, and we're going to arrange them around the atom. Whoops. Thank you. All right? All right. Let me just get this off here. All right. Beautiful. All right. Now remember, chlorine has 17 protons, so how many electrons? 17. How many in the first energy level?
2.
2, and that's all it can have.
So there's 15.
Okay? There's 15 left. How many in the next level? 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm up to 10 altogether. Remember, the total is what?
15.
Total is what?
17.
17. All right? So now I have to go up to the next level. Because the second level is full, first level is full. Could I do this? Could I take one from the
No.
inside level and put? Nope, I can't. You have to fill the inside levels first before you go up. Now we're in the outside level, the last level. How many are going to be there?
7.
7. Total, 17. 7. Did I do it right? 1, 2, 3, 4, 5, 6, 7. Yes. Okay. That leaves me room for 1. Tell me what chlorine wants.
The extra one.
Wants 1 electron to complete its outer shell. Wants 1. Okay? But I'm just a chlorine atom. Where am I going to get 1 electron from?
From the sodium atom.
There are atoms, and I'm on sort of on the middle of your paper there. There are atoms, in fact, there are a lot more that actually want to get rid of electrons than get electrons to complete their outside shells. They're called metals. And the periodic table is mostly metals. Most of the, and I forget what the number is, all right, 70 or something like that. Of the 92 elements, 60, I forget what it is, most of the elements are metals. They want to lose electrons. In fact, that's actually the definition of a metal. Let's take sodium now, all right? Sodium's down at the bottom of the page. See it? How many electrons altogether? Sodium.
11.
11.
11.
11 protons, 11 what? Electrons, okay? All right. 2 in the first shell. Second shell?
8.
8. I'm up to what now?
10.
That leaves me with how many in the last shell?
1.
1. So sodium, what does sodium want? What does sodium want? Sodium wants what? It's got room for what?
Seven more.
So, sodium's going to try to get 7 more electrons. Or is there another option here to get a complete outer shell of 8?
Take one away.
Now, okay, let's see what happens. If I were to take one away, do I have a complete outer shell now?
Yeah.
Yes. So what's easier? Try to get 7 electrons or just get rid of one?
Get rid of one.
So you got one hanging here. And who's looking to get one?
Chlorine.
So sodium says, I want to get rid of this one electron really badly. I want to just all I got to do is get rid of this one electron and I'll be happy. I won't be neutral, but I'll be happy. Are you with me?
Yeah.
Just want to get rid of one stinking electron. Meanwhile, chlorine's over there, hello, hello, I only want one. Can I have yours?
Yes.
Sodium says what?
Yeah.
Yeah. They really talk to each other. They really do. No, I'm just kidding. All right. So what will happen is sodium will give its electron to who? Chlorine. Because it doesn't want it. So it can have a complete outer shell. Now, does sodium have a complete outer shell?
Yes.
Yes. Is it happy?
Yes.
But is it neutral?
No.
And here's what happens. Now, instead of being neutral atoms, they become
Negative.
charged. Negative charge, positive charge. It got rid of an electron, which means it has 11 protons, 10 electrons, an extra positive charge. So chlorine just picked up a negative charge, so it's extra what? By 1 charge, right?
Yes.
Okay. And now they become new particles. They're still atoms. They're still what?
Atom.
But they now have a new designation. And the designation is they now become things called ions. Have you ever heard of ions before?
Yeah.
Maybe you have, all right? Ions. An ion is a charged atom. An atom with a charge. An atom with an extra electron, or it's missing an electron. Okay, are you with me?
Yes.
Now, if this gains an electron to complete its outer shell, sodium loses an electron to complete its outer shell, becomes positive, this is negative, and what do? Now, the magnetic force of positive attracting to negative holds them together, they bond, and what do you have? You have a salt molecule, sodium chloride. And that's why atoms join. They join to complete their outer shells of electrons. And to do that, they can exchange electrons to make that happen. Okay, thank you.
Just in time.